Hey guys, today we're going to talk about geometric probability and inscribed shapes. Inscribed shapes are simply shapes that are drawn inside of other shapes. And before we start talking about those, we need to go over our two-dimensional geometry area formulas. Okay, so we have our square, which is side times side or side squared, rectangle, which is length times width, a triangle, which is 1/2 the base times the height, a parallelogram, which is the base times the height, a trapezoid, which is 1/2 times base 1 plus base 2 times the height, and then the circle, which is pi times r squared, okay, or the radius squared. And in this case, for pi, we're going to use 3.14. We're not going to go any further than just 3.14. Okay, let's look at an example of an inscribed shape. Okay, here we have a square with a circle drawn inside of it. The side length of the square is 10 meters. Okay, and we have a radius on the circle. So to find the area of the square, we take 10 and multiply it by 10, which would be the measure of each of its sides. So 10 times 10 is 100. And then for the area of the circle, we take the radius, which is in this case half of the side length of the square, okay, because the circle extends to the edges of the square. That means that it's touching, so that means that the diameter here across the center of the circle is going to be 10 as well. So the radius is half of the diameter, or half the way, half the distance all the way across the circle. So half of 10 is 5. So our radius is 5. So we're going to do pi, which is 3.14 times the radius squared. Now please keep in mind that when we are squaring the radius, we are only squaring the radius. We're not squaring 3.14 as well, and we're not squaring 3.14 times 5. We're squaring only the radius. So we're going to take 5, multiply it by itself, which is 25, and then multiply that by 3.14 and get 78.5 meters. Okay, so now we have the difference, or excuse me, now we have the measures of the two areas of these two shapes. We have the measure of the outer circle, or excuse me, outer square, which is 100 meters, and then we have the measure of the inner circle there, which is 78.5. So the question is, how does this fit in with probability? Well, what you will ask to do is find, for example, what is the probability of hitting outside of the circle? Okay, and what we need to do in that case is we need to find out how, or what the probability is of hitting outside in these corners here outside of the circle. So what we're going to do is we're going to take the area of the square, and we're going to take the area of the circle, and we're going to find the difference. So when we subtract 100 minus 78.5, we're going to end up with 21.5. We will then take that remainder of 21.5, because the 21.5 represents the small portion outside the circle, and put that over the measure of the entire area of the square. Okay, that creates our probability right there. If we want to take it one step further and make that a percent rather, what we're going to do is we're going to take 21.5 and divide that by 100 and then multiply it by 100, because we're trying to find a percent and we want to multiply by 100 there. So in that case, we end up with 21.5%. So you have a 21.5% chance of hitting outside of this circle. Okay, as another example, say we have this parallelogram with a smaller square on the inside. Okay, what is the probability of hitting outside of the black square? Well, we have a height for the parallelogram of 7 and a base of 8. So to find the area of the parallelogram, we're going to multiply the base times the height, which is 7 times 8, which is 56. And then we need to find the area of the square. The square is a 4 by 4 square. So we're going to take 4 and multiply it by 4 and get 16 meters as the area of the square. So then to find the probability of hitting outside of the black square, we're going to literally remove the area of the square from the area of the parallelogram. So we're going to subtract here. So take 56 and subtract 16 from that. We will end up with 40, and we're going to put that 40 over the area of the entire shape, which is 56. Okay, so again, 40 over 56 is a good starting place for our probability. We have a 40 out of 56 chance of hitting outside of the black square. But let's make that a percent, so because we tend to understand percents a little bit better. So we're going to take 40 out of 56, and we're going to divide that, and we're going to get 0.714, and then we're going to take 0.714, multiply that by 100, and by making that into a percent, and we're going to end up with 71.4%. Okay, folks, we will get some practice on this in class, and I will see you there. Us.